this lesson, we're going to be learning how to find area under the normal curve. So there's two standard normal distribution charts that we're going to be utilizing, the negative and the positive. If we zoom in on one of these, this is the negative one. In this first left column, we see the whole number and the first decimal place. And across the first row, we see the second decimal place. So if we want to look up a particular z-value, we're just going to go down to a particular row and across to a particular column to match the z-score that we want to find. For instance, if we want to find negative 2.52, we would go down to negative 2.5, and we want to go over to the column that is 0.02, and we find the area that's associated with it. This area is always reading a left shaded region, or an area that is less than or equal to a particular z-value. Okay, let's jump in and learn how to find these probabilities. So first of all, if we want to find the area to the left, or an area that's less than, we just look up the value on the chart and we're done. So we're going to take a look at numbers 1 and 3 together, and I'm going to ask that you look at 2 and 4 on your own. The first one, we're finding the probability that z is less than negative 1.45. So remember that a z-value of 0 is right in the middle of the distribution. That's equivalent to the mean. So negative 1.45 is to the left of that center line. And we're finding the area to the left of that, or less than that. All right, let's go to our negative z-chart and look up that negative 1.45. So we're going down this first column until we get to negative 1.4. That's the whole number and the first decimal place. And then we go across to the 0.05 column, and we see 0.0735. So 0.0735 is the probability that we're going to have a z less than or equal to negative 1.45, or just less than negative 1.45. All right, let's jump down to number 3. This is a positive z-score. So when I'm drawing this distribution, now my line is going to be to the right, and our z-value is 0.76. And again, we're finding a left shaded region so that z is less than 0.76. This time we're going to go to the positive z-chart, scroll down until we get to 0.7, and then across to the 0.06 column, and we see 0.7764 is the area that's associated with that number, 0.7764. We see that this is a larger area. It's more than half of the graph is shaded, so this probability does correspond to the picture that we have drawn there. All right, pause the video here, see if you can find the areas that are equivalent to the negative 2.19 to the left and the 1.23 to the left. So numbers 2 and 4 on this slide. Okay, those two probabilities, number 2, 0.0143, and number 4, 0.8907. In order to find the area to the right, or greater than a particular z, we have to first look the values up on the chart, but then subtract those probabilities from 1, because the charts will always read a left shaded region. Let's again take a look at numbers 1 and 3 together. So for number 1, we're finding the probability that z is greater than negative 2.37. All right, let's go to our negative z-chart and look up negative 2.37. And I see that is associated with the probability of 0.0089. Now, that is the area to the left of negative 2.37. We see that this is not the area that we want. We want everything else. So thinking about the normal curve, the area under the entire distribution is 1. So we're going to use complement rule to find the area that we do want. So we're going to take 1 and subtract off the area from the chart. So we're taking 1 minus the 0.0089, and we get 0.9911. So that would be the area to the right of negative 2.37. Okay, let's take a look at number 3 together. We're finding the probability that z is greater than 1.92. So there's a picture of what's going on. I'm going to look up 1.92 on the positive z chart. 1.92 is associated with 0.9726. 0.9726. Again, that's the area to the left. So to find the area that we want, again, using complement rule, 1 minus the 0.9726 will give me that tail region, that right tail region, or the probability that z is greater than 1.92. Okay, and I get 0.0274 as that probability. Okay, pause the video here, see if you can find the probabilities associated with number 2 and number 4 on this slide. Okay, for number 2, when looking up negative 0.49 on the negative z chart, we got 0.3121, but again, we have to use complement rule with that. So final answer is 0.6879. Number 4, when looking up 2.80 on the chart, we get 0.9974. And again, using complement rule, we get the final probability of 0.0026. If we want to find area between two z-scores, we're going to look up both z-scores on the chart, no matter whether it's the positive chart or the negative chart, and then we're going to subtract the smaller probability from the larger probability. Remember that we can never have a probability that is negative, so we want to make sure that, again, subtracting the smaller one from the larger one will give us a positive result. So taking a look at number 1 together, we're finding the area between negative 1.24 and negative 0.87. These are both negatives, so we're going to use the negative z chart and look these both up. So the negative z chart for negative 1.24 gives me a probability of 0.1075. 0.1075. That is representing from this negative 1.24 to the left. Now let's go ahead and look up the negative 0.87. Negative 0.87, I see a probability of 0.1922. And that is going to be from this negative 0.87 again to the left. So guys, we can see that this area of 0.1922 includes this tail region, which we actually do not want to include. So that's why we're going to subtract. We're going to take the 0.1922 and subtract off this left tail region of 0.1075. And that's going to leave us that area in between those two z values. So let's see what we get. 0.1922, and we're subtracting off the 0.1075, and we get 0.0847. So that would be the probability between those two z-values, about 8.47%. Okay, number 2, following pretty much the same process here, guys. We have 1.37 as our first z-value, 2.12 as our second z-value, and again, we're shading between them. We're going to look these both up on the positive z-chart and subtract their probabilities. So looking up 1.37, I see a probability of 0.9147. 9147. And looking up 2.12, I see a probability of 0.9830. So similarly to the last scenario, that 0.9830 includes everything to the left, but I do not want from 1.37 to the left, so I'm going to subtract off that probability. So the larger probability, 0.9830, minus the smaller probability, 0.9147, and that's going to leave me that area in between those two z-values. Let's see what we get. 0.9830 minus 0.9147, and we get 0.0683 as the area between them. Okay, guys, try number 3 on your own, follow that same process, and then unpause the video to see the results. Okay, just because we have one negative z-value and one positive z-value does not affect the process whatsoever. So when we look up the negative 1.67, we get 0.0475. When we look up the 1.45, we get 0.9265. We're going to subtract off that left tail region that we do not want to include in our area. So we're taking 0.9265 and subtracting off 0.0475. That leaves us a final probability of 87.9%. All right, the last situation that we have is when we're asked to find OR areas. So we're going to find the area of each region as we've learned in previous slides, and then add the two areas together. So OR is our keyword for addition. You may remember that from our probability unit earlier in the year, but OR means add. So taking a look at number 1, we're finding the probability that z is less than negative 1.23. So I'm going to shade to the left of that. Or z is greater than 1.78. So we can see that there's two separate areas that we want to include on our normal curve. So let's first find the area to the left of negative 1.23. Negative 1.23 is associated with the probability 0.1093. 0.1093. There's nothing else we have to do with that number because that is the area to the left. So that's the area that I want. Over here, 1.78, if we look up that on our positive z-chart, we see an area of 0.9625. 0.9265. But that is the area to the left. That is not the area that I want. I want this tail region that is to the right. So I'm going to use complement rule with that one so that I can get this right tail region. So 1 minus the 0.9265 gives me a tail region of 0.0735. Okay, so these are the two regions that I want. or means add, so we're going to add these two probabilities together. So 0.1093, and we're going to add on the 0.0735. Okay, I get a probability of 0.1828 as my final answer. So 18.28%. All right, why don't you try number 2, pause the video here, and then unpause to see the answer. Okay, the results of number 2 are shown here. We look up negative 2.18 on our negative z chart, and we get 0.0146. Notice that we have a positive 2.18 on this side. So if you look that up on the positive z chart, we get 0.9854. But when we take complement rule, we're right back at that 0.0146 number. This makes sense, guys, because the graph is symmetrical. So the area on the left is going to match that area on the right. So we're adding those two areas together or just multiplying it by 2. We get a final answer of 0.0292 or 2.92%. Okay, our last slide today is all 4 types that we've talked about, a U-try. So again, pause the video here, see if you can find those areas. Remember the different rules for how we find those areas, and then unpause the video to get the answers. Okay, those 4 questions. Number 1, we just look up negative 2.36 and get 0.0091. Number 2, we look up the 1.32, but we have to subtract that value from 1 once we look it up. So 1 minus 0.9066 gives us the final answer of 0.0934. Number 3, we're finding between, so we look up negative 2.17, we get 0.0150. We look up 1.92 and get 0.9726. We subtract off the smaller probability from the larger. So final answer is 0.9576. And then number 4, we look up negative 0.48 and get 0.3156. We look up 0.92 and get 0.8212. We have to take complement rule of that right side. So we get 0.1788 and add those two probabilities together because or means add. 0.4944 is the final answer to number 4. All right, this concludes the lesson on how to find areas under the normal distribution.